Anyone who uses Amazon Web Services Lambda functions knows that we can allocate 128 MB of default memory to a function, and we can go up to 10 GB of memory. But what about the CPU? How much virtual CPU can we allocate to our Lambda functions, and how is it dependent on memory allocation? Let's explore this step by step. In simplest terms, when a Lambda function is allocated the default memory size of 128 MB, it is provided with 1/16 of a virtual CPU. As the memory allocation increases, the proportion of vCPU allocated also increases. The maximum vCPU allocation for a Lambda function is 6 vCPU, which you can achieve when you allocate the maximum memory of 10/240 MB. The relationship between memory and vCPU is linear. For each 792 MB of memory, you get 1 vCPU. Here is the graph to show you how this scaling works, how this all works under the hood. In the step 1, Amazon Web Services provisions a Firecracker microVM with the specified memory and vCPU allocation. This provisioning is done dynamically, allowing for rapid scaling based on demand. Just a one line about Firecracker is a lightweight virtualization technology designed to provide a balance between the flexibility of containers and the security of virtual machines. Each function runs in an isolated microVM, which ensures that resources, memory, and CPU allocated to one function do not interfere with others. Lambda manages the entire lifecycle of the Firecracker microVM, including creation, execution, and termination, based on the incoming requests and function configurations. The cost of running a Lambda function is based on the memory allocated and the execution time. Amazon calculates the cost using the allocated memory and the duration for which the function runs. Some of the example scenarios are: Scenario 1. Low memory, low vCPU. Functions with minimal memory and CPU requirements can run efficiently with the default 128 MB 116 vCPU. Scenario 2. Moderate memory, moderate vCPU. Functions that require moderate CPU resources might benefit from allocating around 124 MB of memory, 1 second vCPU. Scenario 3. High memory, high vCPU. For CPU-intensive functions, such as data processing or machine learning, allocating the maximum memory of 10/240 MB 6 vCPU provides the best performance. Understanding the underlying architecture of Lambda with Firecracker microVM helps in optimizing your functions for both performance and cost. This detailed knowledge allows you to make informed decisions about the resource allocation based on the specific needs of your application. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.